27. 27, we have a formula we need to use. 27, we're doing, shh. We're doing a dilution on number 27. Dwayne. Katie, what's the formula for when you're using a dilution? It starts like this. M1V1 equals M2V2. Very good. It's kind of like combined gas law. P1V1, P2V2, all that stuff, right? All right. Now, we have to know what our, remember how we set these up like this way back in the old days? All right. Molarity, original molarity is always my stock solution. All right, now this is what I'm going to make. That's the new volume, and that's the new molarity. What you're usually looking for is V1. So we're going to rearrange for V1. And Katie, do you see how that works right there? Yes, so then I plug in my numbers. Do you think this is going to help you, or it's too much work? How long did it take me to do that? Like 5, 6 minutes to make that? Maybe more like 2 seconds. All right. Aaron Crankshaw, what's 3 divided by 6 times 20? 3 divided by 6. Try that. 10. 3 divided by 6 is half of 20. Come on, kids, these days. Josh, what's half of 20?
You said what? 10.
Thank you.
All right, well, if you asked me what's half of 20, I would have said 10 too. You said what's 3 times divided by 6?
Josh, what's 3 divided by 6?
2.
-2.
Try that again. Okay, 5th grade. He's in 5th grade. Okay. All right.
Are you smarter than the 5th grader?
What's 3 divided by 6?
-2.
Very good. Okay. All right. Now, number, it's okay. He'll get a spanking after school. Okay. Number 28.
Saturated.
Jess, see how I tell them how that they should know this stuff already? Yeah. Okay.
You're going to get a whooping when you get home.
28.
It's unsaturated.
I think it's saturated.
Less than the maximum amount that can be dissolved is unsaturated.
Because he looked in the back.
No, because it's under in his list.
Thank you.
You cheated.
Brian Como, you might be the best student we have today. You might be my student of the week.
Well, I thought I was.
No, you are from Miss Palmer. Okay, next. You gonna watch this on Edmodo later?
Answer my question by email.
Maybe. All right. Number 29.
Lock the door.
Everyone loves learning about molarity. Okay? Because then we get to talk about molarity man. Upside down molarity man. Where's Jay Warner? He drew me a lovely picture of upside down molarity man. Jay Warner's going to have to spend a lot of time on Edmodo tonight, isn't he? All right.
You don't care.
What is the molarity of the solution that contains 125 grams of sodium chloride in 4 liters of solution? All right. Kendall, you see what I'm doing here? I'm taking my mass over my liters. Why? Because I know I want liters in the denom, and I want moles of sodium chloride in the numerator. Put it under the colored pencils, please. Oh, did you do all those tests?
Almost all of them.
Are you going to be there again tomorrow?
No, I'll come back tomorrow. I have like a stack of papers like that big.
Oh, good. Okay.
It's not good.
Well, it keeps you busy. Okay. All right. Hey, Dee, who's taking care of ISS today?
Oh, there's some lady.
Okay. All right. What's 125? What do I do mathematically? Will, you know this one. What do I do mathematically? I take 125. What's the mathematical operation I do right here?
On that first part?
Multiply or divide? It's in the denominator. So I'm going to divide. And then I'm going to divide by, again, this number right here. Okay? 125, divide by 4, divide by 58, and I get some fancy number. Hunter, what's my fancy answer on this one? 29?
0.535.
Yeah, the answer on our answer sheet is A.
That's a good answer.
It is. Hunter. All right, next. Am I still on track? All right, we got to get through problem number 45 today, so we got to go pretty fast here.
35 or 45?
No, 45. Okay,
13 minutes.
yeah. According to figure 22.1, how many grams of KBR are needed to make a saturated solution? Saturated. And 100 grams of water at 30 degrees Celsius, so I got to find 30. I got to find KBR. Here's 30. Here's KBR. That's the way I say it. All right. 70 G's. All right. I get 3 tickets for that. All right. Shh. Next. How will I classify? Well, look at my choices. KBR at 50. Let's find KBR at 50, right here. What's the solubility? It is 80.
Same as.
Now, how many solute grams do I have dissolved? I only have 60. So is that saturated or unsaturated? It is, thank you, Ashley. It is unsaturated because I'm below the line. Josh. Next, 32. How many grams of KCl will form a saturated solution? Okay, 200 grams of water, 120 Celsius. You see, there's a lot of variables you have to pay attention to, right, Chris?
Right.
Talking to student of the week, Chris.
That was like a month ago, so that shouldn't count. But I mean,
He's my student of the year. Remember, I only get student of the week.
I was doing another week before. Mine was too.
KCl 120. Chris, what are you saying? Because I can hear you. 60. All right, 60 G's per 100 grams of KCl in this much water. Now, Dwayne, student of Miss Palmer's week,
out of 120, not 100.
it's at 120, but now, no, it's out of 200. So now,
It's out of 100.
It must be one.
no, it's not. It's out of 120 degrees Celsius.
Not grams, that is grams.
I know what you mean, Hunter. You're right. It's out of 200 grams. So if I doubled, Ashley, my water, how much KCl can I dissolve? 120 is the answer, and we're done with that one. All right. Shh. 33, Casey. Which is a polar solvent? Remember, polar means asymmetrical. It has some ends that are partially positive and some that are partially negative. I'm not on the screen. It is water. Why is that? Because water is asymmetrical. You've got these lone pairs that are very negative. You've got these hydrogens that are very positive. All right. Next, 34. A molecule that is positively charged on one end and negatively charged on the other end is... Chris Albert, what do you think?
Positive, negative.
Polar. Very good. All right. What?
You're a good question.
Oh, thanks, Chris. You too. Okay, 35. Sugar is soluble in water because sugar molecules are polar.
What do you think about polar right now?
Massive and low.
Wait for tomorrow or your test day. You might see a bunch of non-polar stuff.
So he said non-polar, I'm just trying to circulate it. Wrong.
So this is carbon tetrachloride, gasoline, benzene. You kind of have to know the formulas for these to know if they're non-polar. But number 36, which of the following will dissolve slowly? It's unstirred, and it is large, okay? Large and unstirred are going to go slowest, most slowly. Number 37. This right here is endo or exo right here? Endo. So it gets cooler. The surroundings get cooler. This is exo. Things get warmer. All right. It also means we have a negative enthalpy change. This means we have a positive enthalpy change. So let's go with Ryan O'Neill. If this type of reaction, which question do we want to answer it for? What is the right answer on this one? The right answer, according to your answer key, is D, cooler. So which one of these graphs are they talking about? This one right here. We'll say that one was graph A, okay? Is that what we need to correct that, Jasmine? Okay. Number 38. How does the energy of the activated complex, where is that? Right here, right? Compare with the energies of the reactants and products. Well, that's easy. Sam, tell me about the energy of the activated complex. It's pretty high. It's higher than the reactants. It's higher than the products. So let's, A. Right on, Ash. Good. 39. The diagram, all right, 39, D is the right answer, but let's look at the, we don't have, it didn't tell us if we're looking at graph A or B. If it's endothermic, which graph were they talking about, graph A or B? Graph A shows it's endothermic. The highest peak, Will, you see that would be activation energy, right? The highest peak is activation energy. All right. In an energy profile graph, the activated complex is represented where, Brian? Top of the curve. These are some quick ones, aren't they, Katie Can? You've got to talk to me before you leave about Edmodo. Don't leave without talking to me about Edmodo. All right. What? Oh, yeah. 42. The heat of fusion. All right, guys, down here is called the heat of fusion. Up here is heat of vaporization. All right. So, Chan, what's the right answer for 42? Chan. Where's,
Is Chan here today?
he's doing thinking. Solid to liquid, very good. He said solid to liquid. That's where heat of fusion is, right there. Okay? Heat of vaporization would be liquid to gas, right, Ashley? Right. Okay. 43. Hey guys, I think we're going to meet our goal today of getting through 45. Why is temperature not changing during these two state changes? Read and evaluate. We know there's no temperature change. Heat is not being released as this shows adding heat. We're not decomposing this. This is not a chemical reaction, is it? Aren't we just going from ice to water to steam? So A, energy is being added to separate the molecules and break intermolecular bonds. Hey, what are you doing? 44, which best describes temperature? This is a basic definition that you guys need to know, average kinetic energy. Number 45. This right here, 45, guys, we are going to use an equation that is on your laminated sheets. Q equals mc delta T. Q is heat. C is specific heat. And you know that this is mass, temperature change. Mass, temperature change. I'm writing these out because I want you to write all of that out. These are the ones that you guys get confused, all right? The words themselves are similar, right? All right, now, let's solve it. This right here is your Q. 5,200 joules is equal to the mass of your concrete times the specific heat, which we don't know, times the temperature change. You don't have to convert to Kelvin here. Divide both sides by m and temperature change. And you will get
Actually, out of the rule because that's crazy platform. These out. I'm going to spring.
All right, that's 45.
Yeah.
number 46.
Oh, when we reach our goal.
Shh. When a reaction is always spontaneous is when you have exothermic and increasing entropy. Nature tends to go toward energy going downhill and entropy increasing. Entropy increasing means we're getting more disorderly. Okay? 47, simple, catalyst. 48, simple, catalyst.
Students and teachers.
We're taking our break. I'll see you tomorrow.
Seniors, your graduation practices are on